Hi everyone, welcome to Math Foundation Academy. So in today's video, I'll be talking about Sieve of Eratosthenes. So let's understand what exactly it is. So before we get into the topic, let's understand the prime number because prime number is connected to the topic of today's video. So what is prime number? An integer can be called a prime number when it has no integral factors except unity and itself. So, for example, 2, 3, 5, 7, right? Then 11, these are the 13th, these are the prime numbers. Because it has only two factors, these numbers have only two factors. One is 1 and the number itself. Number itself, right? This prime number, the concept wise, it's very simple, and in the higher classes, you'll see a lot of questions that are given in different Olympiad exams or competitive exams based on prime number, their characteristics and features. Okay. Now, what is Sieve of Eratosthenes? So, about 22 century ago, a Greek mathematician, Eratosthenes, used a sieve for shifting the composite numbers out of the natural numbers. So it means the remaining numbers will be the prime numbers. So basically, in simple words, this sieve can be used to find out the prime numbers. So let's in today's video, let's find out the prime numbers from 2 to 100. Okay. So what are the steps we should follow so that we'll get to know how many prime numbers are there? What is the logic of sieve of Eratosthenes? This is basically very effective method of locating primes. Right? The procedures I'll be discussing in the next couple of slides. So, I have all the whole numbers are arranged in in columns the way it is shown in the slides. See? So all the numbers from 2 to 100 are arranged in this fashion. As you know, the 1 is not a prime number. 1 is not a prime number. That's why it is out from this table. First, the step is cross out, so circle this number 2, okay, and cross out all the multiples of 2 on the table. So it's highlighted by the red color. So this is the multiple of 2. So whatever has been highlighted here, those numbers are not prime number because as per the definitions, there should be the factor should be only unity and itself. So in case of 4, then it has 3 factors. So 4 has 1, 2, 4. So hence it is not a prime number. So whatever the numbers which are which have been highlighted here are basically composite numbers. So first we have removed all the numbers which are multiple of 2. In the next step, we'll repeat this exercise with number 3. So again, we'll start with number 3. We'll just circle the number 3 because number 3 is also a composite number, right? And then we'll strike out all the numbers which are multiple of 3. So here the multiple will be 3 of will be 6, 9, 12, 15. These are the multiple of 3. It means these are not prime number. So so far we have removed 2, so multiple of 2 and multiple of 3. Now same exercise will repeat with 5. So first we'll just cross the number 5 on this table, and then we'll cross out all the multiples of 5. So here multiples will be 10, 15, up to 100. So these are basically again composite numbers. Composite number. So far we have removed multiple of 2, multiple of 3, multiple of 5. Now this slide will be repeating the same stage, same thing for the numbers which are actually multiple of 7. So 7 and all the multiple of 7 will be removed from here. So basically 14, 21, 28. So these are the basically all composite numbers. So we continue the process. So in the next step, what we'll do, we'll take 11th, because 11th also prime number. So we'll 11, then we'll see 13th, 17th, and finally, and so what I mean to say, we'll take and we cycle the number 11 and we'll strike out all the numbers which are multiple of 11s. So this will be 22, 20, 33, right? Similar way, we'll remove all the multiples of 13th, 26, 39, and then 17, multiple of 17, 34, 51. So we'll continue this process. And then at the end of this process, we'll see that there are around 80 numbers have been striked out. So they have been removed from the sheet. So all the cross numbers here in this table is basically your composite numbers. Okay. Composite numbers, okay. And then the circles, the numbers which are left in the grid of table are basically the prime numbers. Okay, these are the finally these many prime numbers are there between 1 to 100. So what we did first, we started with prime number 2 and we removed all the multiples of 2 from the grid of the table. Then we started with prime number 3 and we removed all the numbers which are multiple of 3. We continued the process for 5, 7, 11, 13, 17, 19, continued. And at the end of this exercise, you will see that there are a couple of numbers are left. So these numbers are basically prime numbers, and the numbers which have been removed from the grid is basically composite numbers. So this is the process which was actually uh, derived by the scientist mathematician Eratosthenes almost 22 centuries ago. Right. So hope you understood uh, the process or steps or methodology how to locate primes. Right. If you want to find the primes from 100 to 200, you can follow the same steps methodology which I have just described, and finally you get to know how many prime numbers are there in the in 100 to 200, right? So hope you understood the concept, um, and you'll be able to do the same exercise for 100 to 200 or 200 to 300 and so on. Yeah. Thanks for watching.